In this video, we will discuss the problem, the Smurfs. The problem says that Geek once visited a magical island where he found a special creature. So Geek has basically found a special creature and he named it as Smurf. Now, Geek noticed a very strange thing there. The strange thing is that the Smurfs resemble the primary colors of light. So now, what are the primary colors of light? So they are red, green and blue. So you can basically see that there are three different colors, that is red, green and blue. Now he talked to one of the Smurfs and the Smurfs came to know that Geek is a good programmer. So the Smurfs suggested a deal that they will ask him one question, and if he is able to answer that question, then they will allow Geek to take anything from their island. So basically Geek has to answer this question that has been given to him, and you also have to answer this question. Now the problem says that the Smurfs possesses a very magical property, right? So there is a magical property in the Smurfs. So where two Smurfs of different color meet with each other and they get converted to one Smurf of the third color, right? So basically what does this mean? This means that if suppose there is a Smurf with the color as red and there is another Smurf with the color as blue, because there are three different colors that can be there, that is red, blue and green, as we can observe. So if we combine two Smurfs, that is one Smurf with a color as red suppose and another with the color as blue, then in that case we'll get the combined Smurf as color with green. Okay, if we have color blue and we get combine it with color green, then the resultant Smurf will be of color red. So you can see that the two Smurfs are getting connected to give one Smurf with a different color, right, with a red color. Now another thing that could be done is if we have a Smurf with red color and we have green color, right, so if we combine these two Smurfs, then the resultant color that we will get is blue. So this is what the problem is saying, that that is the unique property of the Smurfs, right? You can read it again, that they two Smurfs of different color get connected with each other, they meet with each other and they convert into the Smurf of the third color, right? After this, how many minimum number of Smurfs will be remaining after the transaction, right? So the problem says that what is the minimum number of Smurfs that will be there after the transaction. Now the question says that question looks simple to the Geek. However, the Smurfs put another condition. So there is one more condition, right? The other condition is that if you are choosing two different Smurfs, right? If you are choosing two Smurfs, so they should be adjacent to each other. Like if I give you R, B, and then R and G, so you should choose two different Smurfs, two Smurfs of different colors that are adjacent to each other, and then you can recolor them, right? Then you can write another color, the third color, in place of them, right? So they should the pair that you are choosing of different colors, that should be adjacent. Now you need to tell that what is the minimum number of Smurfs that will be remaining after the transformation has been done. So let's quickly consider this example. Let's say that we have been given RGB, RB. So if we have been given RGB, RGB, RB. So what we can do is basically we can see that instead of this we can write a blue. RB can combine to for getting a blue. Then we have B. Then we have R and B. Now what we can do, another thing is that we can combine R and B and we can get a G. Now we have B, B, G. Now what we can do is we can combine B and G and then we can get R. Now we have B here as well. So B and R get combined and we get G only. So we get single Smurf, right? So you can see that the answer for this has been given as 1. Now if you see, this is a good case that if two R's are present, right? So if you will see that there are two Smurfs and both of them are of the same color. In that case, you can basically observe that there is nothing that can be combined and the total number of Smurfs after the combination or after the transformation will still be n. So what we can observe is, the first thing that we can observe is that if all the Smurfs, all the n Smurfs are of the same color, let's say it is R, 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 or it is blue, 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 B, 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 or if it is something like G, G, G. In that case, you cannot make any transaction transformation, and you will simply write that total number of Smurfs in the end is still n. Okay. After this, what you need to understand is you need to understand some cases here. That is very important. And how can you get analysis of such kind of cases? By writing a lot of test cases. You should think about a lot of test cases to get a clear picture about such questions. Okay. Now, if you will observe, so let's say that we have been given another sample. Suppose that we have RR. Suppose that we have something like this. Suppose we have all odds, right? We have R, R, R. Okay. Then we have something like let's say B, 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 and then we have G G G. Okay, so basically you can reshuffle them as well, but basically I'm saying that when all three are odd, okay, when all three are odd, when all three colors, the count of all three colors, when count of all three colors are odd, right? Now if you'll observe, if all the colors are odd, then what will happen? Let's try and solve it. So you'll see that in place of this, I'll simply write what? I'll simply write a G, then we'll have R R, G, B B, G, G, G. Now after this, if I'll observe, so if I combine these two, so I'll get R, then we'll have B, then we'll have B, B, okay. Then after that we have G, G, G. Now after that, I'll combine these two. So what will I get? I'll get G, then I'll have B, B, I have G, G, G. After this, what I'll do is I'll simply combine these two. So I'll get what? I'll get R. Now I'll have B, I'll have G, G, G. After this, what we can simply say is that we can combine these two and then we can get what? We can get a R. Like we have R here, we have G, G. Okay. After this, if you'll observe, so what I can do is I can combine these two. I can get B, I have R here, I have G here. Now if I'll solve it further, so what do I have? R, B, G. Now if I combine, so you can see that if I combine these two, so I'll get what? I'll get a G and I have G here as well. So now you can see that it cannot further be solved. So so the answer is the number of Smurfs remaining after the transactions or after the transformation is nothing but 2 here, right? So you can see that it is 2. So you can observe that when all three were odd, right? When all three are odd, when all three colors are of odd, like odd count, when all the three colors are occurring odd number of times, in that case, what we can basically say is, we can basically say that the answer comes out to be 2, right? Now let's understand what will happen if we had, let's say one odd, only one odd. Okay, if we had only one odd number, only one odd, only one odd color, in that case what will happen? Only one color that is occurring odd number of times. So if we will consider such kind of a case, so let's say we have a case in which we talk about this, let's say we have R, then we have something like B, B and G, G. Okay, you can take a lot of combinations, like you can take something like R, B, G, B, G also, that is also fine. Basically you can take any combinations. I'm taking this for simplicity purpose. Whatever you will take, it will work for, if you have only one odd, so it will work for all the cases. The final result that will derive, it will work for all. After this, if you will see, so I'll have what? RB. So RB, if I combine, so I'll get a G, then I'll have B, then I'll have G, G, right? After this, you can see that if I'll move further, so I can simply say that if I combine these two, so I'll get R, then I have G here, G here. If I'll combine these two, I'll get B and I have G here. Now if I'll combine these two, I'll get a R, right? So you can see that I'm getting R. So I'm getting one, like basically I'm getting what? I'm getting one Smurf in the end as a result. So if only one odd is present, then I'm getting the result as one, right? If only one odd is present, then I'm getting the result as one. If all of them, if the count of all the colors is odd, then I'm getting what? Then I'm getting the answer as 2. If if only one color is occurring odd number of times, if only one color has the count as odd, then I'm getting the final answer is 1. Now let's see what if two odds are there, right? What if two colors are odd number of times, two colors are present odd number of times? In that case, what will happen? So let's consider a case in which we talk about, let's say we talk about R R, then we have, let's say something like B B B, and then we have G G G. You can take any other combination as well. You can take R G R B. You can basically, if you want, you can shuffle this up and then write a particular combination permutation of yours. That is also fine. It will work for everything, right? So now if I combine, so I'll get what? I'll get a G here. I have R here, right? Then I have B B, then G G G, right? After this, I will combine again. So what do I get? If I combine these two, so I'll get simply a R. Then I have R here. I have B G G G. After this, if you will see, so basically you can see that we started off with total size as 8, and now we have okay, so you can see that basically two colors were odd, this color was odd and this color was occurring odd number of times. After this, if you will see further, so what we can observe is, we can observe that now what we are going to get is, if we'll mix these two colors, let's say we mix these two, so we'll get R here, so R R R, okay, and G G. Now if I'll mix these two colors, so we'll get B G R R. Okay, so now we have what? We have R R B G. Now if I'll combine, so we'll get what? R G G. After that, if I'll combine, so what we'll get? We'll get B here and we'll get G here. Now if I'll combine, so I'll get R. So I'm getting one Smurf in the end. I'm getting one Smurf in the end. Okay. So if you will observe one thing, if I'll try to tell you, so you can see that if all three are odd, all three colors are occurring odd number of times, okay, then the answer was 2. Okay, if two are odd, then the answer was coming out to be 1. If one color was odd, okay, then the answer is also coming out to be 1. If all of them are not odd, then the answer is coming out to be 1, right? Now you need to observe one more thing. Suppose that we talk about the even cases as well, right? So if you talk about, let's say you have at least one odd, right? If you have something like this, let's say you have R, okay, and you have BB and GG. Okay, this is when two of them are occurring odd number of times and one color is only occurring like two of them are occurring even number of times and one color is occurring odd number of times. In that case, what will happen if I'll combine these two? I'll get a G, then B, G, G. Okay. Now after that, if I'll combine these, so what will I get? I'll simply get something like R, G, G. I'll combine this, so what will I get? I'll get BG. So I'll combine this, I'll get R. So you can observe that if I have at least one odd, right? If I have at least one odd, if I have one odd, or you can say two odd, then in all the cases I'll get the answer as 1. You can see that I have derived one more case for you when these two colors were occurring even number of times and one color was occurring odd number of times only, right? So you can check it for other also. Like if you will see here, let's say I have R, G and I have BB, something like this. You can try it out for other combinations as well in which only one is odd, right? So you can see here that I'll combine these two, I'll get R here, then R is there and B is here, right? If I'll combine these two, I'll get G, then this is R, then I'll get ultimately B. So I'll get the answer as 1. So if the condition is that if I have one color occurring odd number of times or I have two color occurring odd number of times, right? In that case, if I have one color occurring odd number of times or two color occurring odd number of times, then the final number of Smurfs that will remain in the end is 1. Otherwise, if that is not the case, then the answer would be nothing but 2, you can say, right? So that condition is that at least like either one odd should be there or two odd should be there, but all of them should not be odd. Three odd should not be there. One odd can be there, two odd can be there, but three odd should not be there. That is the case. So let's try and quickly write the code for this approach. So what we'll be doing here is, first of all, we'll be simply iterating through the given string. So let's say we'll have R for counting the number of R colors. Then we'll have B is equal to 0 and we'll have G is equal to 0 as well. Then what we will simply do is we'll simply iterate. So for int I starts from 0, I is lesser than n, and then we'll do an I plus plus. After this, what we will simply do is we'll simply say that if it happens that a of I is equal to, let's say, the color R, then we'll do simply R plus plus, right? Otherwise, we can say that else if it happens that a of I is equal to G, then I'll simply do a G plus plus. Otherwise, we can simply say that if it is the third color, then we'll do a B plus plus. So once we have counted, so what we need to do, we need to check that if suppose that it happens that a particular color, let's say the color red is occurring n number of times, or if it happens that the color blue is occurring n number of times, or if it happens that suppose the color green is occurring n number of times, in that case we need to simply return what? We need to simply return n only, right, as we have discussed. Else if we need to see that if it happens, right, if it happens that R mod 2 is equal to 1, or if it happens that blue mod 2 is equal to 1 if blue is occurring odd number of times, or if it happens that green mod 2 equal to 1. So if at least one of them is odd, like, but I should also check that and all of them should not be odd. Okay, if one odd is there, two odd is there, that is fine, but all of them should not be odd. So if any one of them is odd, at least one or two people are odd, but all of them should not be odd. So I should check explicitly that if R mod 2 is not equal to 0 and uh, R like B mod 2 is not equal to 0 and the color green modulo 2 is not equal to 0. Okay, like basically I should say that if it's not equal, like I should say that if some of them are even, right, if some of them are odd, basically if some colors are odd and all the colors are not odd. Okay, so basically if I'll see this thing, let's say if I write that odd condition, that if all of them are odd, like this is the condition that when all of them are odd, when all of them are equal to 1, right, when all of them are equal to 1, when I do the mod all of them are equal to 1, then this is the condition which I don't want. So I will write a not here, I'll write a not here, that if all of them are not odd, if because this condition, if I'll not use a not operator here, so it will say that if all of them are odd. So if I'll write a not, then it will tell me that okay, if all of them are not odd and one or two colors are occurring odd number of times, in that case I can simply say that the answer resultant would be nothing but 1. Else I can say that the answer would be 2 in all the other cases. You can try it out by doing some dry runs as well. So basically it was a game of odd only. Basically what you can say is, if one guy is occurring odd number of times, at least one guy is occurring odd number of times, and all three are not odd, all three colors are not odd, or if it happens that two guys are odd and all three are not odd, then in those cases you can see that the answer is always going to be 1, because if at least one color is occurring odd number of times, or two color is occurring odd number of times, in that case the answer is always going to be 1. Otherwise that is not true, because if all three are odd, then I'm not going to get the answer as 1. You can observe that, because if I'll see this, let's say if I have R, then I have something like B, and I have something like G, then in that case if I'll solve this up, then I'll get G and I'll get G. So you can observe that for this basic case, when all of them are odd, so I'm getting what? I'm getting a answer as 2, right? So this is how we do this particular problem. Now let's try and compile the code to see if it works for the samples or not. Let's see. Okay, now let's submit it to see if it gets accepted as well. So you can clearly see that our solution was able to pass all the test cases. Talking about the time complexity for this approach, so it is going to be nothing but order of n, and the space complexity is going to be order of 1. If you like the video, the explanation, make sure to hit the like button, comment down understood in the chat in the comment section as well, and make sure to subscribe the channel if you haven't. Thank you.